So I moved this weekend, so I'm really tired. Nothing worse than spending your Saturday and Sunday packing items into boxes, moving boxes, and then unpacking the same items from those boxes. But I moved into a new house. It's looking pretty. I got the sun blaring right into the screen. That probably looks really pleasing to you guys. But I'm sitting on a box on a counter because I haven't set that up yet. But Leetcode takes higher priority than unboxing. So that shows you the kind of person that I am. So let's go ahead and get into this problem. Go Bears. All right, so problem 2460, apply operations to an array. So this is an easy. This is from the contest, I think, this weekend. So this is a relatively new problem. So let's go ahead and get right into it and have some fun while we solve this Leetcode on a Monday. So you're given a zero-index array nums of size n consisting of non-negative integers. Okay, you need to apply n-1 operations to this array, where the ith operation zero index, you apply the following on the ith element nums. If nums I equals num I plus 1, then multiply nums I by 2 and set nums I plus 1 to 0. After performing all the operations, shifts all the zeros to the end of the array. For example, the array 1, 0, 2, 0, 0, 1. Return the resulting array. All right. Okay, so each num is really small. So each num is really small. So let's get right into it. Okay, so I'm trying to think if there's a way. So one easy way I can think of doing this is, and that's probably what we're going to do here. I was just thinking about different solutions in my head. So we had O of n runtime, O of n time, and O of n space. Now, someone's going to be a smartass, and they're going to tell me that there is a O of 1 space way of doing this. But, I mean, look at this. N is 2,000. Who cares? 2,000 indexed additional space, it's fine. So I don't really care that we're going to use O of n space. We'll have a one-pass solution that is pretty quick. So let's just go and do that. So we'll have R. We'll call it res because I've always seen that. And R equals 0 times the length of nums and then 0. So what we're going to do, since we're applying this operation, well, we're applying this operation to each num with num I. So let's do that first. We'll say for I in range, 0 to length of nums minus 1. Why we're doing minus 1? Well, because we're looking at nums of I and I plus 1. So if we're looking at like this array here, right, and we're applying this operation, we look at 0, 1. That's when I equals 0. 1, 2 when I equals 1. 2, 3 when I equals 2, 3, 4 when I equals 3, 4, 5 when I equals 4, but there's no additional one here, right? Like this last item never gets checked as the first item because there's no subsequent item, right? Because we're looking at pairs of 2, right? So that's why we go to -1 here. And the condition is here. Well, if num's I, so that's why it's nice if you use, variables that are the same as the documentation because it becomes very, clear what your conditions are and all that jazz. So if nums I equals nums of I plus 1, what are we supposed to do? Well, we multiply nums I times equal 2, and we set nums of I plus 1 equal to 0. Okay. So that will get us with this condition. But the problem is at the end, we need to shift all the zeros to the end of the array, right? So if we print nums here, right? Oh, this is if they're equal, not if they're not equal. Sorry. So what the hell's going on? Okay. Right, so we have the right situation here, but we need to shift these zeros to the right. And that's not as easy as it sounds, right? Because we're gonna have to look at each of these, and that could affect our runtime because we have to look at each zero and like shift it all the way over. And what if all the zeros are on the left and they need to be on the right, and there's only one, so then you end up shifting zeros like this. Now you have an n squared time runtime algorithm. So what about instead, when we look at nums, since we have this res array with R, you say, well, we could just collect the non-zero numbers, right? So you can say res of R and R equals nums of I times 2, and then we'll append 1 to R. So we'll increase R. And then we'll just set nums I plus 1 equals 0, because we want to make sure that that condition is met. The reason why we don't need to set nums I to, we don't need to double nums I is because since we're shifting over, we'll never see nums I again. So then at the end, or otherwise, nums I R plus 1 again. So if we see a number like this, 1, 2, 1 doesn't equal 2, but we still want to collect the 1 at the front, and that's what this is doing. Unless nums I is 0, because if nums I is 0, then we don't collect it, we just print it at the end. So now if we print res, if we return res, should get the right answer here. Oh shit. Okay, so, well, I didn't even think about this edge case. So if this last number, because it never checks this last number because it's only looking at pairs. So we look at, so nums of, if nums at -1, if there's a last number, then res of R equals nums at -1. Because there's a non-pair number at the end we need to check. Oh, dude, I'm doing terrible. Yeah, so it was checking if two numbers are 0. If two numbers are 0, you're not supposed to treat them. Man, I did terrible. I had 2 edge cases to consider. All right, so this is kind of messy, so is there a way to fix this? If I can't really fix it like that, but I can just do this and make it shorter, and that's worth something. All right, there we go. Okay, so what's the runtime of this? Well, we need to create, like I said before, this is O of n space right here, right? Because we need to create a return array of size n, and then we just look at each number. So that's O of n time, O of n space. All right, guys, I just moved, so I'm really tired. Hopefully, the remainder of the week, I can get into some more difficult problems, some more fun stuff. But, all right now. All right, see you guys.